Hi, welcome to Math 1350. This video is going to be over the first section of notes, which is chapter P.1. And we're going to look at algebra expressions and dealing with real numbers. All right, first, the difference between rational and irrational numbers is rational can be expressed as a quotient or a ratio or a fraction. All right, so numbers like 1/2, 2, you can think of it as 2 over 1 makes it a fraction. They're rational numbers. The only number that can't be in the denominator is 0. Otherwise, it's not a true rational number. That becomes very important later on. So a and b, if we look at a fraction of a and b, a over b, both of these numbers have to be integers. They can be negative, they can be positive, a could be 0, but they have to be integers. So a is 2, b is 4, then a over b is 2/4 or 0.5. Right, so we can write rational numbers as fractions. We can write them as decimals. So 1/2 is 0.5. And we can write them as percentages. Say 50%. Right, an irrational number is a number that has a decimal that either doesn't terminate or repeats. So for instance, pi is irrational. It's 3.14, and then it keeps going with the numbers. So square root of 2, that is considered irrational. No, it's going to be 1.41 and then a lot of other digits after that. Right. Square root of 49, though, if we take the square root of that, we get just 7. So this is rational. Right. 1/3, it can be written as a fraction, 1 over 3. And as a decimal, it does repeat. And so this makes it rational. And 1/8, it's a fraction. So we can write it as 0.625. And so it is also rational. There's certain properties that you don't have to memorize these properties, but it's good to know how to use them. So for example, if we're adding two numbers, a plus b, it's going to be the same thing as if we did b plus a. So 2 plus 3 equals 3 plus 2. Same thing with multiplying. 3 times 2 equals 2 times 3. Okay, those are the commutative properties. The associative properties adds in a third term to it. So if we have 3 different numbers, it doesn't matter which ones we add first. So 7 plus 4 plus 3. We can add the 7 and the 4 first and get 11 plus 3 is 14. Or we can have the 4 and 3 first and get 7 plus 7 is 14. Oops. Okay. We can do multiplication. So 7 times 4 times 3. We can do first 7 times 4 is 28, and then multiply that by 3. And so let me do that real quick. Get 84. Or we can do 4 times 3 and get 12, and then 7 times 12 is equal to 84. Or any order. And then there's a distributive property. if A is on the outside, it's multiplying a sum of B plus C. We have to distribute this A to both B and to C. So 7 times 3 plus 4. Right, if we do the math there, we get 7 times 7, which is 49. But we have to distribute it to get it, to break it apart. So 7 times 3 is 21. 7 times 4 is 28. And so you get 49 as well. Now, it's maybe not necessarily to actually do the distributive property there, but if we had 7 times 3 plus x, we would know that we would have to distribute this to make it still remain the same value. Now, dealing with negatives, if we have -1 on the outside of a variable, we can write it as just negative a. So -7 is the same thing as -1 times 7. Okay, we just leave off the 1 a lot of times. The negative of a negative is written as -1 times -1 times a, which -1 times -1 is 1a, which can be written as a. So negative of a negative makes it a positive. So negative of -7 turns into a positive 7. Okay. A negative number times a positive number gives you a negative value. So -7 times 3 gives me a -21. Or 7 times -3 gives me a -21. Okay. Basically, odd number of negatives gives you a negative value. Even number of negatives will give you a positive value. So -7 times -3. You really can look at this as -1 times -1, which is 1, and then 7 times 3, which is 21. Sometimes it's important to distribute a negative or factor out a negative. That negative has to go to both, just like a number does. So negative a plus b is negative a minus b, or plus a negative b. Right, and so negative a minus b is going to be negative a plus b, because this negative sign turns that one positive. And we can write it as b minus a. So negative of 7 plus x, it's going to be -7 minus x. Negative of 7 minus x, it's going to be -7 plus x. All right, the next important thing is fractions. When we multiply fractions, we multiply the top and then we multiply the bottom. So a over b times c over d is a times c over b times d. So 2/3 times 4/5. 2 times 4 is 8. 3 times 5 is 15. If we divide fractions, so a over b divided by c over d, you flip the second fraction. It's always the divisor. Divisor is flipped. Okay, so you get a divided by b times c divided by d. Then you multiply the top. A times d over b times c. All right, so 2 divided by 3, or divided by 4 divided by 5. We turn this into 2 divided by 3 times 5 over 4. And we multiply the top. So we get 10 over 12. And then make sure we do fractions. Both of these are divisible by 2, so you get 5 over 6. When we add fractions, if the denominator is the same, we can just add the tops and keep the denominator as 1. So a over c plus b over c is a plus b over c. So 2/3 plus 1/3 is 2 plus 1 is 3, so you get 3/3, and then that ends up being 1. If we don't have the same denominators, then we have to find a common denominator. Now there's a couple ways of doing it. You can find the lowest one, or fail-safe method is you just multiply the two denominators, as that makes your one denominator. But you're not just multiplying them. What you're really doing is you're multiplying the first fraction by the denominator of the second over the denominator of the second. So d over d. And the second fraction is only multiplied by c over c. You're not changing anything in terms of numbers. You're multiplying by 1 for both of these terms. But it does allow you to have the same denominator, so you can add them. So if we had, let me wait for it to save, 2/3 plus 4/5. We'll multiply the 2/3 by 5 over 5, and we'll multiply the 4/5 by 3 over 3. Okay, so the denominator is going to be 15. The top is going to be 5 times 2 is 10, plus 4 times 3 is 12. So you end up with 22 over 15. And then if you can reduce. I don't think this reduces. Okay. If we have common factors, so we have factors c and c on the bottom, and there's no addition signs, we can divide them out. So if we had, do it this way, 4 times 3 and then 2 times 3. I'm going to do it long ways first. 4 times 3 is 12, 2 times 3 is 6, so it divides out to 2 over 1. Okay, or we can cancel the 3's. Oops. I'm going to have to make this into 2 parts here because I'm going to have to charge my tablet. Cancel this to have 4/2, which is also going to be 2 over 1, and both of these will equal just 2. Cross multiplying, if you have something like 3 over 4 equals x over 5, simplest way to solve this is multiply the 5 over and then multiply the 4 onto the other side, and you end up being able to solve this. So you have 15 equals 4x, and then divide by 4 and you get 15 over 4. Alright, since my tablet's starting to die, I'm going to make this into 2 videos. We'll start sets in the next video. Alright, I'll see you then. Bye.